Welcome to this video where I'm going to show you how to do one of the two exercises in section 7C that we may not have time to do in class time because of all the issues that have come up this semester. It's problem number 31 on page 447, and I've got a picture of it right here where it says further applications. This is a picture of it in the ebook. Again, page 447, problem 31 and problem 32. If you want to refer to an example in the book, you can also go in and look at page 441 and look at an example in the textbook. And again, I want to make sure, because a lot of people are very visual learners, I want to go to page 441 in this ebook and let you see where it is. It's right there. There's a specific example that you can go by that will help you understand how this problem is. What expected value is, we know, even if we choose to purchase lottery tickets or scratch off cards or whatever we're doing, we know that the odds are designed to beat us. We have those occasional winners that win millions and often win maybe $5 or $1,000, but it's designed to beat us. And I wanted you to know mathematically how this works by giving you a couple of examples to go by with the probability involved with it. The arithmetic is a bit tedious, but it is not difficult to do. It's just basically multiplying, adding, subtracting. Nothing complex should be there. Now I'll go back to page 447 and look at the actual example, which will be produced right here. If you look at this in the book, we're looking at a game called Powerball as an application. This is real world math, and they're saying that this table gives recent prizes. It gives you the odds, or the probability. Odds are different. It gives the probability of winning a particular prize. So we want to find the expected value of winnings for a single lottery ticket when we're given these prizes. The grand prize is just listed as grand prize on the example, but in number 31 you'll notice that it says the grand prize is $30 million. So what I've done is I've made a chart, or about to make a chart, where I've got the values there. What I'm going to do is place in there the information that you have in this problem, starting with the word grand prize, the word 200,000, etc. And I'm going to fill this in. We first of all buy a ticket, which of course is going to cost $1. The grand prize in this particular case, I'm going to change that to where it's going to be $30 million, and I'm going to leave off the dollar symbol and just write it like this. That's $30 million. So where it says grand prize in the book, I've just replaced that. The next value that will be in there will be $200,000. Again, just putting the commas here just for the people who are very literal with their reading. Then there's a $10,000 prize. Then there is a $100 prize. I don't know why they've got this twice. I thought there might have been a mistake in the book, but there isn't. After that, it's a little bit tedious here. I apologize for what's happening. There's a couple of $7 prizes for the Powerball, and there's a $4 prize and a $3 prize. You may be thinking, where am I getting these numbers from? I'm getting these numbers in this first column and the event from the exercise in the book over in the first column. Grand prize is $30 million, which is stated down in problem 31. It says the grand prize is $30 million. I get the 200,000, the 10,000, all that stuff going down the list. Then I've got the chances of winning that particular prize, and I'm going to write those down. The grand prize is going to be, and I probably should have put these in a column that says value. So I'm going to go ahead, and so that it makes it a little less confusing, I'm going to go ahead and change this. I'm going to delete this column. Don't worry about this right now, and I apologize for my little goof. It's not really a goof, it's just a very slight oversight, and I don't do these videos for perfection because I just don't have the hours to make them perfect. I'm going to delete this column right here and make it just a little bit easier to work with by making this a little bit wider for us. Okay, the ticket purchase, first of all, in fact, I'm going to go ahead and write these items in here first. The 30,000 prize, it says 1 in, it uses the word in. They said the chances of winning this first prize are 1 in 149 million. Let me get this right. 1 in 195,249,054 chances. Now, instead of writing the word in right there, probability is always a fraction, I'm going to put a divide symbol. I don't have the little dot, underlined dot, like a lot of you write on your homework. What we have on the computer is that little / sign, which is on the calculator. Those are my chances of winning the big prize of $30 million. If I look at the next one, $200,000, it says the prize chances are 1 in 5,138,133. Again, I'm changing the N to a divide symbol because that's what we'll actually calculate in a few minutes. For the 10,000, it's 1 in, I think you got the idea now, so I'll just put the spaces there, 1 in 723,145. For the 100, 1 in 19,030. Thing you have to do is be careful to type these numbers. A lot of you have reading issues maybe, or oversights when you're looking at stuff, being forgetful, so just be careful about this. The next one's 1 in 13,644, 1 out of 359. I'm just copying these numbers from the chart, and again, for the very insecure, the highly visual learner, I'll show you where I'm getting these numbers from in just a minute. I think most of you know this, but just in case you don't, again, refer to the exercise, and I'm just using this second column right here that says probability. I'm changing the word N, I-N, to a divide symbol like you would have the / that you would use on a calculator. The only thing I've left out right here at the very top is going back to the example on page 441. When you purchase the ticket, you've actually spent $1 on that ticket to buy it for one ticket. And so we'll write the value for that ticket as -1. So the ticket purchase is -$1 because you spent $1 on the ticket. And the probability that you bought a ticket, by golly, it's guaranteed you bought a ticket, so we put a 1 right there. Now what we do right here is we take these two numbers in the first row and we multiply these together. So what I do right here, and I'm going to keep that selected, I'm going to type -$1, -1 times 1. Now what's -1 times 1? Well, you know that answer. That's pretty basic math. The answer is -1. I'm going to write that right there. For the next one, I'm going to multiply 30 million, 3 followed by 7 zeros, times 1 divided by 195,000. I'm going to write this out. I don't type the commas in the calculator because they don't exist in the calculator. So this is how I would enter it in the calculator. This is not hard, it's just that you have to be careful with the numbers. I'm typing in 30 million, 3 followed by 7 zeros, sorry. 1, 2, 3. Did I type this right? 4, 5, 6, 7 zeros. Times symbol 1 divided by 195,249,054. Now I've calculated this ahead of time for this video, so you don't have to watch me do the math because you can punch this in the calculator. And you don't want to round this off like a lot of you have a habit. You don't like integer, you don't like fractions and decimals. You like whole numbers. You cannot do that in these problems. You have to round it to so many decimal places. The book and my math lab recommends 6 decimal places. When you do this in the calculator, you're going to get an answer something like this: 0.153649. Okay? And if you want to round it to 3650, that's okay. I'm not splitting hairs about this. The next thing I do is I type in 200,000, 2 followed by 5 zeros, times, hang on a second, I'm having to do this with the computer, 1 divided by 5,138,133. The answer right there will be 0.03. I know a lot of you probably, I hope you're not, but some of you will just write these things down off the video, which is a little dishonest because you need to know how to do this, because I'm not doing number 32 for you. I'm only doing number 31. I'll do the next one. 10,000 times 1 divided by 723,145. And I'll go ahead and write these answers in here. Hopefully I'm getting these right. And sometimes I'll forget myself. I have to be careful. 013828. The next one, what am I doing? 100 times 1 divided by 19030. I hope you're getting these in the calculator now. They're just a little bit tedious. They're not difficult, but they're a little bit tedious to write down. And sometimes, in my case, the the frustration, the ADHD or whatever sometimes gets a little aggravating. We just have to discipline ourselves to hang on. That just goes with college classes. The next one, 100 times 1 divided by 13644. And there you go. I'm keeping on going, digging through this. 7 times 1 divided by 1. Divided by 1. Let me start over. I'm getting myself confused. I'm tired. 7 times 1 divided by 359. The answer, 0.019498. 7 times 1 divided by 787. And some of you may be saying, I don't care about this. Care for this semester, and then you won't have to care anymore. It really gives you real world information. 4 times 1 divided by 23. Carry these out again to 6 decimal places. That's just what's recommended by your book. And finally, 3 times 1 divided by 62. Again, it's not hard to do. You just have to take your time in getting this done. Alright? Once we have this chart set up, and you don't have to write this in a chart form, it just makes it easier for the video. I'm going to scroll up the screen where you can look at this. Now what I will do is I will add these numbers together, and I was wondering when I first did this, I thought, what am I doing wrong? And then I'm going to subtract 1 from it. So if you want to, you can put in the computer, in your calculator, minus 1 plus, and I'll actually write this out so you can see what I'm doing, minus 1 plus 0.153649 plus 0.038924 plus, and you keep on adding these together until you get to the very end of the problem. And once you do this final plus business, then you'll hit the equal mark. You should get a negative answer. The answer that I got was negative 0.530324. And since this is money that we're talking about, I'll round that to dollars and cents. Since there are no dollars here, round it to negative 0.53. In other words, what happens for every ticket that I buy based on these probabilities of winning, I lose 53 cents on each ticket that I buy. Okay? If this is something that you still don't understand, you need to get with someone one-on-one or with me face-to-face so I can go through it with you. This is the best I can do in presenting it when you're outside of class. Now, that is the expected value of the winnings for a single lottery ticket. So for a single lottery ticket, I'm writing this out visually, for a single lottery ticket purchase, I would expect to lose 53 cents on each ticket. Now, of course, we could win the grand prize. We could win $100. We could win $10,000. But theoretically in math, this is what will happen. Now, what the question also says in the blue directions, it says if you spend $365 a year, let's say you buy a ticket every day of the year, 365 days. The question that comes up in this on page 447, it asks you, at the end of this blue area right here, it says, state how much you can expect to win or lose if you spend $365 per year on the lottery. In other words, if I spend $365, if I spend $1 a day, I buy 365 tickets, what I would do is I would multiply $365 times 53 cents to find out how much I would lose for the whole year. So I would type in 365 times decimal 53. It's 53 cents, remember, is decimal 53. And hit the equal mark. And I should get roughly around $193, something like that. So I would lose $193.45 for the year if I bought a lottery ticket each day for 365 days. I'm spending $1 on each ticket, so I'm spending $365. and I'm losing 53 cents based on the calculation I did up here with the table. Now for some people this gets very confusing. This is where you need to read the textbook page 441, you need to replay my video, or you need to ask someone for help. I hope this gives you some benefits in doing the two problems that I've assigned in exercise section 7C. The other problem, number 32, would be done exactly the same way, except the difference in problem number 32 and problem number 31 is instead of the grand prize being $30 million, the grand prize is $10 million. So all you'd have to do, if you watch my video, all the calculations have been done for you except for this one. You would just do this one with $10 million instead of $30 million. So this is the only number that would change. And then do your arithmetic, add that column right there together. See how much you would lose per day. It'd be a certain amount of cents as opposed to many dollars. And then multiply it times 365. Hopefully this video helps out. If it doesn't, please contact me.